To finish up this worksheet, we are going to practice naming cycloalkanes. In the first one, the name is provided for us. Remember, with a cycloalkane, the longest carbon chain is the ring, and we number the ring starting at the carbon that has the substituent, and then we name and locate the substituent. One carbon substituent is methyl. That's in your table 12.2. The methyl is on carbon 1. With rings, you can leave the 1 off. You can leave off the location of the substituent. But if that's confusing to you, you don't have to leave it off. You can include the 1 and call it 1-methyl cyclohexane. Here's our next example. The ring is our longest continuous chain of carbons. We want to number the ring starting at the carbon with the substituent and then numbering around the ring. We want to locate and name the substituent. It's on carbon number 1. And it is a 1,2-carbon substituent. Look at table 12.2. A 2-carbon substituent is called ethyl. Put the name of the substituent first. Follow it by the name of the parent chain. This is a 5-carbon parent chain. Look at table 12.1. 5 carbons is pentane. When it's in a ring, it's cyclopentane. Here are some examples of cyclics that have 2 substituents. So again, we're still going to find the longest carbon chain. We are going to number it so that we put a substituent on carbon number 1. So we want either one of these 2 carbons to be carbon number 1. We saw an example like this in the notes in the previous video when we have 2 choices of potential number 1 carbons. We'll use the alphabet to help us decide which should be number 1. So we want to take a look, before we number, we want to take a look at the substituents and decide what their names are. Up here on top we have a 1-carbon substituent. Its name is methyl. And then over here on the right-hand side, we have a 2-carbon substituent. Its name is ethyl. And again, the names are coming from table 12.2. Ethyl comes first in the alphabet, so it's going to be on carbon number 1. And then as we continue to number around the ring, we want to move next to our methyl substituent. We want to get to our other substituent as quickly as possible with our numbering. So we want to number it in this order. So our ethyl is on carbon number 1, and it comes first in the name because ethyl comes before methyl alphabetically. And then we follow that up by 2-methyl, and then the name of the parent chain, cyclohexane. So here is our last example. We want to find our parent chain, which is always going to be the ring. We want to number that parent chain. Carbon number 1 needs to be one of these 2 carbons with a substituent. To help us decide which carbon it should be, we're going to look at the 2 substituents. This one up here is called chloro. This one down here is called bromo. We want to give the number 1 position to the substituent that comes first in the alphabet. Bromo versus chloro. Bromine comes first alphabetically, so its carbon is going to be carbon number 1. And then as we continue to number around the ring and trying to decide which way to go, clockwise or counterclockwise, our goal is to get to the chlorine as fast as possible, which means that we want to go counterclockwise so that chlorine is on carbon number 3. We are going to put the name together, bromine first in the name because of the alphabetization. Don't forget its location. It's 1-bromo. And then our other substituent, which is on carbon number 3, that's 3-chloro. and then the name of our parent chain. This is a 5-carbon molecule. If you look at table 12.1, that's pentane, but this is a ring, so we call it cyclopentane. And the last thing that this worksheet tells you to do is go back to the molecules at the very beginning of the worksheet and name them. So what I want you to do right now is pause the video, not yet, don't do it yet. Pause the video, go back up to that top of the worksheet, the 8 molecules in 4 boxes, and try to come up with their names. And when you finish that, unpause the video. But don't unpause it until you get them all named. Okay, so now hopefully you've got all of them named. Here are the names of these 8 molecules. In the first box, these 2 molecules were identical, which is why there's only one name here. Because they're identical molecules, they both have the same name, 3-methylhexane. And then over here, these 2 molecules, these are both dimethylcyclopentanes. One of them is 1,2-dimethylcyclopentane, and one of them is 1,3-dimethylcyclopentane. And that's pretty common for constitutional isomers, for them to have names that are almost identical, but the numbering is a little bit different. In our next set down here, we have this one I'm giving you methylcyclohexane, or maybe you called it 1-methylcyclohexane, that's okay. And the constitutional isomer is 1,2-dimethylcyclopentane again. So here's an example of constitutional isomers. Their names are just totally different from each other. So sometimes they're going to be similar in terms of they're almost the same, but the numbers are a little different. Sometimes the names are just going to be totally different. And then last but not least, you have hexane and cyclohexane.